I'm just digging this up again, and I wanted to try to explain what a few of the processes, what goes on. Half of them are left quite unfinished, but maybe by revisiting it, I can just hope to kind of get some inspiration again going. So basically, you have here's all the pieces. Here's them arranged on the board. Each piece has quite an identical set of code, and mostly I've tried to arrange it so that the piece's code works out what it itself is doing, but not how it operates as part of the whole game as a whole. That part's taken care of by other code sections, mostly this master, which is sort of the game controller. But there's a few others I was working on for specific tasks, like this one is reading in a starting position script line, which is not a standard created by me. I'm just trying to interpret it to work in this game setup. I'm adding a few other features here. This is basically a script that just follows. You can't see it because it doesn't have any actual physical thing, but if I give it this and tell it to run, it's just something to follow the mouse pointer. So basically I'm using it to find out where the mouse pointer is, and when you click, which piece it's touching, basically which piece is currently clicked, and that becomes the active piece. Anyways, let me just remove that annoying thing. So it doesn't have any physical aspect to it. It works together with this other sprite, which has these different faces. Green means a current move, yellow means a current valid move, and red means a current valid capture. I kind of broke the part where it sort of writes itself out. Let me just see if I can just make that a little bit work for a second. Right now it has no MT2 move range. Okay, no. Let's communicate with this guy to feed it there. Move range. Okay, it's updated its move range there. I'll just pull that out of here. Let me put it back in. And now I'll just do something that lets it didn't want to update. What's move control at? Okay, so this is becoming quite a bad. Move control's 1. Let me just set move control to 1. This is becoming quite a bad video. I'll try to edit this out. Okay. And let me just try to run that again. Okay, there we go. So there you just saw it. Could you stop? Oh, it's running the active thing. Let me just stop the script. Okay. Okay, so this piece is, I just put it in the moves a queen would make, just for sake, even though it's a rook. So if it's sitting there, it can move on this straight line, it can move on this diagonal, it can move up straight, and it can also move here and capture these two pieces. In the background, it actually knows it can, it knows that a move is possible here, but doesn't go any further. I use that for basically, I don't want every piece has an idea of where it can move at any one time since the game starts. But I don't want every time a random piece moves, let's say this guy moves over here, that this piece has to calculate its new move range. So what it does is, it will only calculate its move range. This is the idea, I haven't set it up yet. If this piece moves, this piece moves, this piece moves, or this piece moves, because basically that kind of unblocks a new option for it. So it's going to look again. Or any piece sitting in one of these moves. The movements are held. This is a grid of 64 potential tiles. One I think is here. 64 is up here, but that depends on if the board gets flipped and stuff. There's a few modifiers. So it reads 1, 2, 3, 4, 5, 6, 7, 8, 9 through 16 on up like that. I use an exclamation mark to indicate that its own pieces move, so it can't actually go there. That stops it from doing a calculation, which is move divided by here, this one. Divided by 1 equals itself. That won't work because it doesn't make any sense. However, I use a dot to indicate it's a capture move, because that divided by itself does work. It equals itself. Divided by 1 equals itself. And that's just to tell it to change color here. If there's a dot at the end, it will switch to a red color. So in the case of those two. Okay, so that's kind of updated. Basically, this guy only has the active pieces list of moves. So I basically just did that to force feed this one into that. And in the background, there's this thing, which I'm not really doing, but using that sprite that tracks the movement, it's supposed to, let me do that and see if it works. No, because I stopped the script. Okay. Oh yeah, okay. In the background, it's going to validate. You see this green circles moving where my mouse moves. What it does is it's behind the scenes, this one is tracking where the mouse moves. If it's within this square, it's additionally looking, are you within the boundaries? It's actually looking at which square you're hovering over. If I'm hovering over this square, it's not a valid square of, where the queen can move to. So no update is happening to the green circle. You can see there. You can see there I can move it. If I move it, however, to a valid square, it takes a little while, but it does find out that this is a valid place. So basically, the idea is when you drag and drop it, it will snap to, if you have it floating around here, I don't want to click because it will turn this off, but if you have it floating here, it's supposed to snap to the nearest valid square and validate the move that way. So you can't put a queen, for example, where a knight would go, etc. And you can see in the background here, this is constantly updating. It's constantly reading the list to see if it's within there. So that kind of works. But there's an issue with deleting the clones, which these guys are little clones of the one sprite. It's just copied itself multiple times. So I kind of gave up on that for a while. Let me just stop these scripts here for now. Okay, so that's that. What else to explain? Okay, so each piece, how is that working? Firstly, how is it finding out where it goes on the board? Okay, when a piece is told where to go, this is the code that each piece has. This one's a bit extra because I'm just playing around with how it's communicating with the movement tracker. Okay, but firstly I'll just show this guy over here. So the piece identifies its square. It always has one square it's currently on. The square is position. I use the temporary position variable. And when it takes its position, it then needs to find out where this actually translates, where they're on the board, so they can all line up nicely according to the center of their current square. I have a constant set, which is the block distance, which is this WH. That's set at the start of the game to be 34, because that's just how big each square is here, top, height, and width. And coming back over to it, the row is how many are in a line, which is always 8 both ways. So position is where it's at, so if it's in 64, it's in the top left corner square here. 3.5 is just a constant to the left and right. You see origin is the center, which is here. And mod is the current side that's in place. So if it's black and white, there's a function to flip the board, which I don't really have in place fully, but I can show you from the background. Switching, well, the background will just, you see here, those ones flip basically, and the pieces are supposed to flip. This piece up here will end up down here, and vice versa. So they'll go across in a diagonal way, and that flip instruction is coded in the pieces, which I could tell it actually. I can broadcast flip, it might throw stuff off. Okay, so I'll just see if that works. There you go. So you can see that it happened quite quick, but all the pieces, so this would happen when the side switches and you want to play from the bottom end of whichever side you are, if you're black or white. So this this rook should be going over here. Just check that that's happening. Ah, it goes there. I think that's just, is that correct? So right now it's at h6. And now it's at a6. It's just an exception because it's not actually been assigned a certain other variable. But I think all these other pieces are doing the correct thing. Let me just try that again. Okay, I'll touch it up a little bit. Okay, anyways, so that's it flipping. Yeah, so this it uses to find its x and y position. Basically, it puts its square number through this function to find its x position. This will tell it where to go on x coordinates, and this one, which is slightly different but uses all the same variables, will find its y coordinates. And I've used the inverse of this as well in the reader here, here to retrieve where it is on the chessboard, so 1 through 64 positions, based on what its x and y coordinates. So this is just the inverse of that. So term 2 is going to try to arrive at the position. So maybe it's on square 64, and based on what it is, its x value, so then it takes it through that. This is all the same variables, the block height, the active side, and row is 8, obviously. I don't use row for the x because it just basically moves, for y it moves out in a multiple of 8, and then for x it just moves out a few steps from that, from this line. So it just moves out from that for that specific row. Okay, so that's how it puts it in place. Each piece has its unique piece ID. Black rook, there's 2 black rooks. So it has the name BR1, 2. This is more for my own, like the programmer convenience. It doesn't actually read its name, unfortunately. So that one also is BR. Then there's a duplicate. You have several of the same kind of piece. So this one is set at 2. That one's set at 1. So that's uniquely identifying those 2. The pawns, obviously there's 8 of them. So you'll have, you know, the last dupe ID is 8. And the first letter of each piece name is the side. So black pawn and white pawn, just to differentiate them. And pawns are having a little bit of an exception, that they can additionally be a queen, they could be a rook, and any one of them could be any piece aside from a king, or another pawn of a different dupe ID. So, because you never downgrade back into a pawn. So that's settled by at the start of a game. The pawn is reset again to be a pawn. The other pieces don't need that. They're always the same dupe ID and the same piece ID at the start of the program. But I don't know who takes care of this. The Fen reader or the master, I think, it does this little thing looking for duplicates of a piece above a certain standard. So the standard rook count here is 2, standard knight count is 2, the standard bishop count is 2, and the standard queen count is 1. And if all those are met in the starting position, then the pawns will just, they'll stay as pawns, and you might have 5 pawns on the board or 3, but that will be the case. If any of these are in excess, so you have 3 rooks in the starting position, you have 2 queens, one of the pawns will be told to promote to a queen or a rook based on its least favorite dupe ID. So we'll try to do the dupe ID of 8. It'll start with 1. If 1's taken, it'll go to 2. If 2's taken, it'll go to 3. If 3's taken, it'll go onwards like that. So that's done for that. You can, of course, you can have 1 rook. So you can start with 2 rooks, 1 gets eaten, and then you promote another pawn into another rook. So now you have 2 rooks, and it's not above the standard, but that's not a problem because at the start of the game there's 2 rooks allotted to be rooks anyways. So they'll just identify as that without any pawn play. So the same as done for black, I explained, is done for white. There's no difference there. Okay, so that's how each piece initializes. So it uses these blocks to get its dupe. It uses this block to tell it where it is on the chessboard. I'm playing around only this rook. So each piece has, the code. I'll just show you. I'll just cycle through the pieces. And you can see that very little, if nothing, changes. Except for the pawns have a little bit more. But they all, again, have that little bit more of the same share. I'm still building the code now for a piece's legal moves. And I put that all in this rook. But eventually, it's going to get split up by each piece shouldn't have more legal moves than what it can actually do. Again, the pawns will be an exception, that they'll need the legal moves of a lot of other pieces. I handle that here. If it's told it needs to update its legal moves, it'll do this at the start of the game or every time it can legally go further because another piece has moved out of its way. I'll start with the rook one, the rook refresh. Okay, so the rook is quite simple. It can go left, right, up or down, but obviously if it's sitting here it can't go right, so there's got to be something to tell it to stop looking right because you're at the edge. And again, the edge is quite relative because I use just a simple chessboard like this. I'll show you the master chessboard list. I use this to track all the pieces that are on. I've just pulled this black rook out of position temporarily, but otherwise you can see, it does start up here. So the black knight is here, BN, BB is black bishop, BQ is black queen, and then king, and then it repeats again, bishop, knight, rook, goes down into all the pawns, that's all those BPs. 0 means there's nothing on the board. Again, this guy's just temporarily there, it's not actually there on the chessboard. White pawns, and the white major pieces opposite here, and 64 is actually, so it's actually this square here. And 1 is up here. But that's relative, it can, as you can see, you can flip. Okay, so that's the chessboard. So as you can see, like for this rook sitting in, this would be position, I believe 48. 49 is on the chessboard, but it's not in the same row, so it's gonna need a special function to tell it stop looking, you can't go this way because you're at the edge of the board. When I did another game, I had like a value for position 49, and then it jumped to 50 was here, and that value was just some null position. I told it when you get to that stop, but I think that's kind of a bit clumsy, so there's another way to handle it. And I call it crawl. I don't know what the correct term, but crawl just basically means to move left to right. Okay, I have a crawl library. I use L for left, just for concise, to be concise. R for right. W for towards white's direction, so that would be down the board, I suppose, and B for towards black's direction. I did have the words written out, but afterwards, because of this flip thing, I found it more convenient to use up and down relative to, I'm just thinking right and left might also need to be configured to that, but basically relative to which side was playing, up and down is flexible. Okay, these are actually, turb1 is the limit of a left search. So say your square ID is 48. You do 48 minus 1. You modify it by how many items are in the row, and you get the remainder of that. So remainder of 48 minus 1, 7, because that's 47 divided by 8 leaves a remainder of 7. That means you have 7 steps possible to the left. So you're sitting here, you can go 1, 2, 3, 4, 5, 6, 7, and you have to stop. That's the limit of how far you can go. Versus the right limit is a little bit longer. It's this function here. So 8 minus 1 minus the square ID minus 1 modified by row. So it's this little part, but then it's also the length of the row subtract 7. Length of the row less 1 subtract 7. I have to use this minus 1 annoying detail because the mod function, if you have mod 8, it will return 0, and I can't work with 0. I need that to equal 8, so I use minus 1, and basically when you return 0, you don't move at all. But if you return 7, yeah, anyways. So I have to add that minus 1 here. So anyways, to sum it up, 48 put into this function will return 0, which means that you don't need to check to the right. There's no valid square here. Up and down, again, so this is just looking how many steps up. This is the function to look up. It's 48 minus 1, and the floor divided by 8, 7, and the floor function, so I think that's 6. It's like 6 points, no, it's 5 point something, 5.825 or whatever, 875, and then the floor of that would just be 5. So you can go 5 steps up, which is what you can see, 1, 2, 3, 4, 5. And then the down crawl, again, the reverse the same way as the right was the reverse of left. Down is kind of row minus 1, take away that function of up crawl, and you get, when you put it through there, you get 2 steps down possible. So it does that, it sets the limits. Okay, then it comes over to the default crawl. And basically all these other variables allow null. Null is always input as 0. So that's an empty space. Stop is its own piece. So if it has an exclamation, if it has its own side prefix to the name, and then pin is if there's a king, it's another function to see if a piece is being pinned because there's a king behind it. So it's going to send a message to that piece that it can't move because of a reason outside of what this check looks for. And it goes through this and basically tries to go to the limit of, these limits set here, but it will stop if it reaches its own piece, another piece, etc. Or the edge of the board alternatively if it doesn't meet those limits. And then that square gets added into its movable range and compiled, and I use these. This is where that exclamation mark gets added if it's its own piece. This is the stop if it's enemy piece. There's a slightly different procedure for how knights are trying to move because they can jump over pieces, so they're not stopped by their own piece or an enemy piece. They can also they only need to do their movement once. So if you think of a rook has 1 step, 2 step, 3 step, a knight does 1 step here and stops. So it doesn't do another step to here and another step to there. So they have a bit of a different way, but I use sort of the same groundwork of this crawl library, because I still have to set the knight's maximum limit, so it can't just, you know, if it's sitting here, it can't do a movement over here because that's the edge of the board, the artificial edge. So that's the knight. The king's got, the king can't move into check, so it has another, it has to look through other pieces' move range to see if it's trying to step into an enemy's move range, then it's not allowed to move. The pawn has also a weird exception because it moves and captures in 2 different ways. So in one way it could move it at a diagonal, but only if there's an enemy piece there. So that's a bit of an exception. It can also, otherwise it moves straight if there's no piece there. But it can't move at a diagonal if it's an empty square, unlike other pieces that they don't have this restriction. And on its first move, it can also move 2 squares, so that's a slightly different analysis. The rooks, bishops kind of use the same mentality. The bishop just does a diagonal movement. Oh yeah, let me explain about, so term 1 was its limit. Crawl change is the movement on the chessboard. So when it wants to go left, you know, and it was, let me just find 48. So it's sitting in 48. It wants to go left. It needs to look at 47, right? And 47, as far as this list is concerned, is -1. It's 1 position lower than 48. So that's the crawl change there. When it wants to go right, it's the opposite. It wants to try to go to 49, but it can't, obviously. But if, say, it was in 47, and it can go 1 to 48, so the crawl change would be 1, +1. If it tries to go down, it's actually going 8 places lower. So from 48, it's jumping down to place 56. Yeah, so it would go to here. So that's a whole row jump, which is signified by this over here, crawl change by row. If it's going up, it's the opposite, it's a negative row change. A diagonal move is considered, I do it in 2 steps, it's considered a move left and then a move up. So its net change, I believe, is 7, but rather than programming diagonal, I just reuse this library and I say go left, then up. So bishop's doing that for its movement, and a queen just uses the bishop space and the rook space to find its moves, and then it puts it all into that this move library, move range list, which should get updated if another piece in its way, like I said, moves out of the way. All that's done here, and I hope to just move this code. A king uses this, it uses the queen's move range, but it only goes 1 space instead of a unlimited amount of spaces. The bishop, yeah, again, so the rook has that. The bishop goes, yeah, so left when B, which is down. So left when, so go left when down, go left when up, go right when down, go right when up. The rook just goes simply up, down, right, left in 1 step. The queen, where's the queen? The queen goes, it does the rook set and then it does the bishop set here. I just didn't want it to reset its range. And the knight does a bit of a weird one, which is not worth explaining now. So that's that. That's sort of the in-game play. I'm trying to use like a rule tracker list to keep an eye on other terms of the game, such as can you move en passant, what's the current move Is there a check happening which restricts what the other player can do? Is there a checkmate happening which ends the game? Funnily enough, it won't know automatically that someone's lost. You have to force a loss. How many pieces are captured? Oh yeah, when pieces are captured, they can also sit here. And I have a function for that, similar to the chessboard. They just line up along here neatly. And if they're sitting here, then they're actually given, I'll just show this. Here, this if square ID is greater than 0. If it's less than 0, it means they're captured. They're given a negative. Term 4 will be where they are in like a captured list. So the first one will be here, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're in rows of 5. And they're given that ID, but just as a negative term. So basically, none other operations are only looking to apply for active pieces. They're basically set as an inactive piece, a negative square ID. So it's not treated on the board for other operations. I've gone to using, okay, so that's a rule tracker. I need to rename this one as term library, and I just use it for a lot of, all the piece names, because I also have to translate them into capital and lowercase names, because some, I think PGN or FEN for black or white use different lowercase and uppercase, and OUBuild doesn't differentiate, so we did find a kind of hack way with some other students on the forum to sort of force a differentiation check. All these costumes are in capital letters, and this sprite just, if it's a lowercase letter, it won't be able to match it to one of its costumes, so it will be able to find that it's lowercase and therefore a piece of black, I believe. So this master sprite again is the game controller, and that library is basically, because I started getting so many terms, so it's just trying to house all the terms. So rook, if it's in brackets, that's sort of an identifier of what the term following is. Those are rook names, knight names, bishop names. And I'll always order it white, in that case white first, then black name. Pawn is also blank. Sometimes PGN, if a pawn's on that square, it just says the square name, doesn't say the piece name. Further, like breaks, castling terms from FEN. You can put comments in PGN. I have to be able to read that. This is the default starting position, which is mostly arranged as here, in case that gets reset, so it always has a copy. The FEN reader takes its starting position and it runs it through. It breaks it up into words. I'll show the active FEN, if that's here. Okay, here's the active FEN. So it breaks this into words of little pieces. There's a format. I didn't invent this. I'm just trying to read standardized ones. This first part until here is for the pieces that are actually sitting on the board. So it breaks it into words of between these backslashes, forward slash, and then reads it and writes it to the chessboard over here. Once it's done that, which is quite a bit of this part, these mod blocks, and that's this part here, read chessboard. Read extra is then the part following that instruction, which is like whose side it is, white's turn. Can both sides castle and where? King or queen side. This one's open. Both sides can castle both king and queen side. Is it en passant possible? Special pawn move? No. The dash says no. How many half moves have there been since a pawn's moved or a piece is captured? 0. What's the current move? Which is 1. So that's the FEN term. Those are all these blocks. Read that. I try to do something clever with the term. So term 1 and 2 is sprite specific, meaning that this sprite's term 1, the master sprites, and 2 is not shared at any one time by this guy's term 1 and 2 and this guy's term 1 and 2. They both have their own version of that sprite with the exact same name. However, I do want to share some of these flexible term variables with each other. For example, when this one's sending a message with a specific variable to that one. So that's saved in 3, 4, and 5. Those are across the game unique variables. They're not different in each sprite. And I have to reuse this block actually a lot of times when it wants to find out, for example, read what the en passant square actually means, or what character I'm looking for when it's a king or a rook or whatever, or the side. So it just sets it to a term, and it just goes through the term library I showed in the other one, that all the sprites can access that list. That list is also shared by all of them. It just goes in there and it pulls out, it searches through until it pulls out the header and then finds the relevant character it needs to use for its part of the code. Yeah, so once it's read that, it's arranged the chessboard, the game ready to go, and I need to fine-tune a lot of all the gameplay mechanics, of check, of piece moving, and eventually at some point, once all those are working, I want to try to program an engine that can use this setup to play chess basically at a better and better level. But that's like, I don't know, the bloody clones of this sprite I can't figure out, and I want this feature to work just for the usability, and it's just not working. It doesn't clear the clones well. Let me just show what I mean. I'm going to set move control to 0. So immediately deleted all the clones. But now if I set it back to 1, sorry, let me get rid of these annoying lists that are taking up the chessboard. Okay. Leave move control, take off the active fin. Okay. So I set it back to 1, and I'm going to try to run this script again. Oh, it actually worked. In the past it was mucking around with this. I don't know. Anyways. And I'll just show wide view if I mod this to 0. I'll just put that up there so you can see it. So now I'm clicking set to 0, because there's a control in here. This is basically controlling when when all these functions are running, they're supposed to stop as soon as a move has happened, which is like when you drag and drop a piece, and then it's not supposed to continue letting you drag and drop it again. So that's going to go to 0, and it's removing all this, and you basically, ideally, when it's done, the piece is sitting there in its next legal place. Anyways, that's all. Sorry for the ramble. It's a bit of a project, but yeah, hopefully get these sorted, load, save, all this fun stuff, all these buttons, timers, that's all going to come in place soon. Yeah, bye.